We don't actually need to draw the grid in this question. We've got multiples of 3, 5, and 7 all being given different marks, and we're interested in how many have more than one mark. So it might have 3 or it might have 2. And so let's first of all look at ones. It might not necessarily have 2, but let's look at multiples of 3 and 5, and that is multiples of 15. Okay, this one's quite quick to do because it's going to be 150 divided by 15, which is 10. It's going to be 10 multiples of 3 and 5 in there. So they're all going to have a red mark and a blue mark. Right, next let's do 3 times 7, so multiples of 21. Okay, so for this we do 150 divided by 21. Well, 21 is actually 21 times 7 is 147. So it's going to be 7 remainder 3. The main thing is there's going to be 7 numbers that are divisible by 21, therefore have a red mark and a green mark. Okay, what's left over? 35. 5 times 7. 150 divided by 35. Well, 35 times 4 is 140. So it's going to be 4 remainder 10. So 4 numbers um, which have a green mark and a blue mark. Now, the only thing we've not thought about is that some of these numbers will also be divisible by all of them actually. So how many will have a green mark, red mark, and a blue mark? And that's going to be multiples of 3 times 5 times 7, which is that 105? 21 times 5, 105. And there's just going to be one number there that has all the marks. So what we have, but the thing is, um, we've counted it here, we've counted it here, and we've counted it here. That one number, 105, has been counted 3 times, whereas I only wanted to include it once. So for my final answer, how many cells have more than one mark? It's going to be 10 plus 7 plus 4, but that 105 with which has got 3 marks, but I've counted it here, here, and here, so I need to minus 2 so that I only count it once. That's really important and probably the most subtle part of this question. So I'm going to get 21 minus 2, I get 19. That's E.